Hi students, welcome to Electronic Device and Circuits video lesson. This is Rahul and Naresh. Today we are going to discuss about direct coupled amplifier under the multi-stage and feedback amplifiers unit. The agenda of the today's class is upon the completion of the period you will be able to know the circuit of direct coupled amplifier, operation of the direct coupled amplifier, the frequency response of direct coupled amplifier, advantages, disadvantages, and applications of the direct coupled amplifier. Revision. We have already come across the multi-stage amplifiers and their necessity. So we know what is a multi-stage amplifier. First of all, multi-stage amplifier means it is having two or more stages of amplifiers. There is one stage of amplifier consisting of one transistor amplifier. The output of first stage is connected to the input of the next stage, and so on. So that is a multi-stage amplifier. Then what is the necessity of this multi-stage amplifiers? See, the output which is produced by the single stage amplifier is not sufficient to drive the output. So we need larger outputs to drive the load. To increase or to get higher gains, multi-stage amplifiers are necessary. We have also discussed the gain, bandwidth, and frequency response of the multi-stage amplifiers. And RC coupled amplifier working and frequency response. RC coupled amplifier we have discussed, as well as the transformer coupled amplifier working and frequency response we have discussed. Okay. Let us see what is a RC coupled amplifier, already which we have discussed in the previous classes. Just to go through it. So here is the circuit diagram of the two-stage RC coupled amplifier. Here, so you can see the interconnection of two stages by using the coupling elements resistor and capacitor, collector resistor RC and coupling capacitor CC. And we also know the biasing resistors R1, R2 and uh, emitter bypass capacitor CE, the temperature stabilization resistor RE. So we also know the working of the RC coupled amplifier, and we discussed the frequency response of the RC coupled amplifier. Here is a graph showing the response of the RC coupled amplifier, where the frequency response is low at low frequencies and high frequencies. Here it shows at low frequencies and high frequencies. The frequency response is low, and at mid frequencies the frequency response is flat. And two-stage transformer coupled amplifier also we discussed in the last class. Here it shows the diagram of two-stage transformer coupled amplifier, If you compare both the RC coupled and transformer coupled amplifiers, the difference is the RC and CC are replaced with the transformer. Here you see. Okay, so RC is replaced with the transformer primary and CC replaced with the secondary of the transformer, which is replacing the wire between R1, R2 and base of the Q2. Here it is. Okay, here it is connecting the secondary of the transformer. Okay, let us see. This is replacing the wire between R1, R2 and base of the Q2. Okay, by using the transformer, here we are coupling the two stages. The first transformer coupling the stage 1 and stage 2, and the second transformer coupling the output. Okay, this is about the previous classes. Okay, and let us go to the today's topic, that is a direct coupled amplifier. Okay, what is a direct coupled amplifier? So in many applications, extremely low frequencies, that is less than 10 Hz signals, are to be amplified. So example of low frequencies are photoelectric current, thermocouple current. At low frequencies, capacitors and transformers are not used as coupling devices, since their size become very large at the low frequencies. So to use the capacitors and transformers at low frequencies, we need to design the capacitors and transistors of a very large size, so which is difficult and bulkier. So we are not going to use this capacitors and transformers at low frequencies. So, and as no coupling devices are used, the coupling of amplifier stages is done directly. So as we are not using any capacitor or transformer for coupling, so how to connect the output of the first stage to the next stage? So we are using a simple wire and connecting the two stages. So that is direct connection. So that is the reason why it is called as direct coupled amplifier. So that is, one stage is directly connected to the next stage without any intervening coupling device. So this type of coupling is called as direct coupling. So here the block diagram of two-stage common emitter cascaded amplifier. Okay, first stage is the input is given to the first stage. The output of the first stage is given as the input to the second stage. Here is the input given to the first stage, and this is appearing at output of the first stage, and the same is given to the second stage. The same is given to the second stage as the input. And the final output is collected at a second stage. Okay. The circuit diagram of the direct coupled amplifier. Here it shows the circuit diagram of the direct coupled amplifier. See, there are three transistors. Okay, that is three stages. Okay, the input signal which is applied to the transistor 1, base of the transistor 1 here. Okay, and